Okay, so we actually discussed about the threading module now. So now we have seen how to actually create threads and how to run code in parallel. And now let's discuss on actually we discussed the manual way using the threading module, or it's actually an old method, and we have newer methods to use, and we have actually a much more easier method. This was actually just to show you how the things actually work. So now let's actually take a look at the concurrent futures module. So, so in actually later versions of Python, they have actually added something called a thread pool executor. So we can actually use that now. So now actually we don't need any of these. So we don't need to use threads this way anymore. We don't need this thing anymore. So we can comment this out. We don't need this. Now we also don't need this threading module. We are not going to use it. We are actually the concurrent or the thread pool executor is actually in the concurrent module. So we have to actually import concurrent dot futures dot thread. So now we have actually imported it. Now we have to actually use this with a context manager. So first of all, we have to see what a context manager is. I'll actually explain it in so I'll explain briefly what a context manager is and what is or why is it actually used for. So context manager, they actually allow you to allocate and release resources. So for example, we cannot use too much resources at the same time. For example, if you are actually doing some file operations or if you are actually working with a file or a database, you have to actually close it once you stop using it, or else it is actually going to cause problem for the system crashing, and it can actually cause a lot of problems. So to actually manage this type of resources, we can use context managers. So that's it, that's the basic thing. You use context managers to actually manage your resources, allocate them whenever needed, and deallocate them whenever actually you stop using them. So in Python, you can actually use context manager using the with statement. So you use context manager using the with statement. Now what you have to say is we'll say with concurrent dot futures dot thread pool executor. We are actually using this thing. So let's just give it a small name, because we need to use this thing. So whenever we use this, we can actually shorten it or give it a shortened name. So we'll call it executor. And okay, so now we have our executor. So now if we actually now we have some options, or we can actually use some functions or methods. So one such thing is actually the submit method. So you can actually use the submit method to execute a function actually. So for example, you want to execute this do function in threads, you can use the submit method. So we'll declare a variable for it. We'll say f1, and we'll say f1 is equal to executor dot submit, and we have to actually specify the function here. We don't have to execute it. So if you want to execute it, we'll actually specify the braces here. So we don't need to execute it, we simply need to pass it. And after that, with a comma, we actually specify the arguments inside the function. So here for seconds, we can say maybe 2. Okay, so submit method, what it does is actually submit method, it actually schedules a function to be executed, and it actually returns a future object. So I'll explain it once again. So submit method actually returns a future object. So what a future object is, it actually encapsulates the execution of our function, and it will actually let us see if the function is running or not, or it will actually let us view the state of the function, whether it is running, whether it is done or not, and it will also allow us to grab the result of the function. So if we just grab the result, we'll actually get the return value of the function. So in this function called do, we are not actually returning anything, we are actually printing it out. But if I just remove this done sleeping, if I just change it to return, I can do that. I can say return. Now it will actually return done sleeping. It instead of printing it, it will actually return the value for. So now if we still want to actually print this done sleeping, or if we just want to print this string called done sleeping, we have to actually print the return value of that function. So to actually do that, we'll actually say print f1 dot result. So now we can actually run the program. If I say run the program, so it says sleeping for 2 seconds, and it actually slept for 2 seconds, and then the program finished, and we printed the finishing time, or the time that the program took to actually finish it. So now we can actually see that we actually achieved the same thing. So if I run the program again, we can actually see that we did the same thing that we used to do with our normal thread method. We had to actually do we had to actually write a lot of line of code, and it's actually a lot less compared to that. So it's actually quite useful. So now if we actually want to run this multiple times, we can actually run the submit method multiple times. So we'll actually say F2, and we'll just copy paste that again, and let's change the second to 1. So yeah, that's it. Now let's print f2 dot result as well, which both of them should be the same anyway. Now if we just run the program, okay, the program actually took only 1 second to complete. If it actually was doing this the normal way, it should have taken 2 seconds. So now this actually got, or it's actually completed in just half the amount of time. So that's actually great, right? We saved a lot of time. So you can actually save a lot of time when we are running multiple things, or when we are actually executing something multiple times, or not just 2 times, maybe 100 times, 1000 times, or we can save a lot of time. Now let's see how to actually run this multiple times, say maybe 10 times or 20 times, or how much you how much time you want to run it. So we could actually use a for loop as before. We could actually use an f1, f2, f3, up to f10, and then actually use submit method on all of them. So but that's actually not really practical, and that's a really bad practice. So actually we can use a for loop here. That is also an option. So but we are actually going to use a list comprehension techniques here. We have actually discussed about list comprehensions before. You can actually check them out if you haven't already. So let's see how to actually do this. So we don't need any of this now. Okay, so now to actually use the list comprehension method, so we can actually say we can actually declare a variable. So we can actually declare a variable here called results, or whatever you want to call it, and we'll say results is equal to, and we'll declare a list here. We'll say executor dot submit, and we'll pass in the function name, and 1 second. We have to actually sleep for 1 second each time, and we'll say for underscore, this is actually a throwaway variable. We have discussed about it before. So we'll say for underscore, or a throwaway variable in range of 10. We are actually going to execute this 10 times. So now to actually get the results of this, so we have actually created a variable called results, and now actually we are running the function for 10 times. So now we can actually, we have to actually print out the result, right? So we have to get the result. So to actually get the results, we can use another module in concurrent futures module called as completed. So this will actually give us an iterator that we can actually loop over, and that will actually give us the results once they are completed. So it will actually be printed out in the order they are completed. So to actually use this, we have to, okay, so we can say for f in concurrent dot futures dot concurrent dot futures dot as completed. So inside this we'll have to pass our results variable. So I'll tell you what it actually means here now. So it actually returns as an iterator, so something that we can actually loop over or iterate over, and that is actually this object. So this will actually return something that we can actually iterate over. So we are actually iterating over that using this f variable, and now we can actually print the results using the f dot results method just like before. So now if we just run this code, okay, so this thing got kicked out, the program actually started and it actually executed 10. So now we can actually see that it actually run it 10 times in just 1 second. Actually earlier it actually needed 1 second to execute it once, but now we can actually execute it 10 times in just 1 second. So we get a huge speed increase there, or a huge speed advantage there. So to actually prove my point, so I actually told you that this will be printed out in the order they are completed. So the first thing that is completed will be printed out first. So to actually just prove my point, I am actually going to do something here. So we'll actually declare a list here. We'll actually say, we'll actually give the different amount of seconds to sleep for this function. So for example, this function is sleeping for 1 second. So let's try and give it different values, and let's see what happens. So for example, I have a variable, or I am actually going to declare a list called seconds, and I'll actually pass in 1 2 3 4 5. And then what we actually need to do is, so now what we are going to actually do is, we are actually going to say that so here actually we are going to modify this. We'll say for sec in seconds. So now we are actually iterating over the seconds. So we are actually going to sleep for a particular amount of time. Let me actually just change this in the reverse order. We need to actually in 5 4 3 2 and 1. So yeah, now now everything else will be the same. So okay, so we also have to actually change the variable name a bit, because we have already taken the variable name called seconds. So we need to actually change this to something. We'll call it seconds this way. So now, so we are actually changing the variable name a bit. We are actually, so we actually changed the variable name here from seconds to secs. So we actually changed it because we already have a variable called seconds. So that is not allowed in Python. We cannot have two variables with the same name. So now let's get back to the topic. So what we are actually doing here is we have a list here with some numbers 5 4 3 2 1s, and we are actually, instead of the seconds value, we are actually passing this value there. So first it will actually sleep for 5 seconds, then 4 seconds, then 3 seconds, then 2 seconds, then 1 second. So now let's actually add an f string here and pass in the variable called seconds, so we can see how much time it actually slept or sleep. And I think that is it. So what we are basically doing here is, we are actually passing different values for the number of seconds we actually want to sleep. So now if we just run the program, so if we just take a look at here, you can see that it started by saying sleeping for 5 seconds, 4 seconds, 3 seconds, just as in the order of this list. But then when we actually if you just take a look at here, it has actually reversed. So it says done sleeping for 1 second, 2 second, 3 second, 4 second, and 5 seconds. So what happened here is we actually used the as completed method. So as it was actually completed, the 1 second one was actually completed before the 5 second one. So as it was actually completed, it immediately printed it out. So instead of waiting for the whole thing to complete, it actually printed the one that was actually completed first. So that is why we can actually use as completed method to do these things. Now let's take a look at the map method. So we can actually do a lot more with map method. Map actually runs the function with every item of a list or an iterable. So for example, I have a list called seconds here, so it has some item inside it. So if I just pass this function, so for this argument I can actually pass in this list, and it will actually apply all those values to inside to that function. So it will actually apply all those values inside the list to that function. So we can actually use the map method to do something like this, something similar. So we can actually comment out all of this. We don't need any of these. So we can actually say that results, the same variable as before, results is equal to executor dot map, and we'll pass in the function. We'll just pass in the function called do, and then the list that it should apply. So we'll apply this seconds list here. So now we have actually done that. Now in the case of map method, it will actually return the results in the order they actually started. So earlier in the as completed method, we saw that once it was actually finished, it got printed. But for this map method, it doesn't work that way. It actually prints out in the order it actually got started. So the first one, the started one was actually 5, so it will start with 5 and then it will actually end with 1. So that's how it actually works. So now we have to actually iterate over this. So I told you that it actually returns an iterator or an iteratable. So to actually iterate over it, we can actually say for result in results, and we can actually print out the result. So now if I just run the program, you can see the program actually started the normal way. It actually slept for 5 seconds, 4 seconds, 3 seconds, and if we just come here, you can actually see that it actually works or it actually printed out in the exact order it actually got started out. So we started by sleeping for 5 seconds, and we also have stopped here by sleeping for 5 seconds, or it actually printed in the same order in which it actually got started. But if you actually look at here, you can see that the time is actually, or the time took to actually complete the script was exactly the same, or actually it is actually nearly similar. So we don't actually experience any lag or any delay when using this method. This method is actually very similar, and it actually takes the same amount of time, approximately same amount of time here. So but if we just want, the only difference is that it actually prints out in the order and it actually got started. So that is the only difference between the only difference here. Now another thing that I would like to tell you is that if an exception occurs in this thread, so for example some kind of error occurred, it will not be displayed while actually it will not be shown while actually executing them. It will only be shown while retrieving the result. So it will only be shown when we actually use this when we actually retrieve the results here. So you can actually add some kind of error exception or try exception blocks here. So it won't actually affect the execution of our program. Only if we try to retrieve it, we'll actually get an error. So that's one thing about threads. So now another thing, in our older methods, in our normal threading method, we had to actually use the dot join method to make sure that all our threads complete, and only after that it should actually execute the final time it took. So it should actually finish all the threads. So for that we actually use the dot join method. So but here we just don't need to do that because it is automatically done. So even if we just remove this, even if we just comment this out, and if we still run the program, it is going to join this automatically. The time taken for the script to be completed is being printed here, even if we don't use the join method or anything. So that is that's actually an advantage of this newer method. So it's actually a lot less complicated than our older threading method, and you can actually use or get the same functionality. So that is all about this threading method. So now we'll actually finish this by doing a real life example of downloading images from the internet. For example, if you are a person who actually does web scraping or something, you actually probably know you have to actually wait a lot of time to get the response from the internet. So we send a request and they actually give us some kind of response, and this actually takes a long time. So in such cases we can actually use these threading modules to speed that process up. We'll be doing a little bit of downloading. We'll be doing a real life example of downloading the images from the internet. This is actually a really fun project that I just got from the internet. So let's see how to actually do it.